Integrated Math 3 students, we have our next lesson today over continuing on equations of circles. I'm glad I pieced these out. We're taking them one section at a time. Today we're going to be very algebra heavy, even though it's based on the geometry idea of circles. We're going to be doing a lot of algebra calculations, so make sure you got your notes ready. Let's go ahead and get into it. Okay, so in your notes, draw a line from where we left off in the last lesson, and go ahead and write in this section finding the center and radius of a circle from the equations. And we have our first example here. So go ahead and put example. Going to be the easier of the examples that we're going to be dealing with. And what I want you to do is I want you to, based on what we've learned and what we know about the circles and their equations, I'm going to pause the video and I want you guys to try to figure out what is the center, which needs to be an ordered pair, right? So we need an ordered pair. Leave some space. Okay, and then the radius is going to be one singular value. So I'm going to pause it and let you guys try that. Okay, so you had a second to answer this. Now let's go ahead and find the answer. Now the center from this first one, we know that we need H and K to go in here. H and K need to go inside of these parentheses. So we're going to write that over here, but let's go ahead and identify what H and K are. Well, this is H and this is K. Now, a lot of students make the mistake, and we learned this last semester through our different algebra approaches, and a lot of my in-person students notice this. We actually have to change the sign of this 3. It needs to be negative, and that's always going to be typical when you're pulling out those values from these parentheses here in this context. Okay, so it's -3, +8 is actually the center of this circle. All right, there we go. So hopefully that makes sense. Not too bad. Let's talk about the radius. So the radius is not 100. Remember that 100 is r squared. We wrote down our formula yesterday for the circle. So that r squared is equal to 100. So how do we get r? Well, we got to square root both sides. Okay, so we're going to take the square root, and that means the radius is going to end up being 10. So you always have to take that square root of that last value. Okay, so this is the answer to the question. All right. Now, like I said, this is sort of the easier type example that you're going to see. We're going to go to the Delta Math examples, and things are going to crank up a little bit in the difficulty department, okay? But I believe in you all. I have 11 practice questions that you all have to do for this section. The rest of them didn't have that many. There's 10 here for the equations, but I feel like those are pretty straightforward. 6 here. Next lessons, we'll be talking about area of a sector and arc length. But let's go ahead and look at these. Now, you have video examples that you can use to help you. After you miss a problem, you can get the solutions. But we have an equation that's not in our general form for a circle, okay? So we are going to be working this out in sort of a different way than what we just saw. Because obviously it's not in that standard form of a circle. But we got to be able to find the center and the radius. So let's go ahead and get some instruction on this. Write this as sort of your next example, like example 2. Okay. So I'll give you, go ahead and write that down. X squared plus y squared minus 6x minus 2y minus 71 equals 0. And we still want to use, for us to find the center and the radius, we still need to have an equation in this format. Okay. What we're looking for now, obviously our equation is not in this format, okay? But we can manipulate it. So we're going to be using algebra to force this equation to look the way we want it to, okay? Now, something that's going to be helpful for this is to think about the equation like this. If I can rewrite my equation into something that looks like this, that's all that square actually means, is I'm writing that term twice. I'm going to have to handwrite. I'm going to do r squared. Okay. This is sort of where we want to be at. Where we want to be. Let me move this over. Okay. So keep this in mind as we start working through this problem. Okay. So the first thing that we want to do, so in your notes, make sure you have this problem written. We want to rearrange this to get all the x's together, right? We have this x variable that's by itself on the left and the y variable on the right. So we're going to rearrange this like so. X squared minus 6x. Okay. We have plus y squared minus 2y. And then I'm also going to go ahead and move this constant over, okay? Because it is kind of in the way. So we're going to go ahead and move that. I'll write these steps out to the side. I'm going to say what we did here, right? So we're going to say group up the same variable terms. Move the constant to the other side of the equation. Alrighty. So we've done that. That's sort of this first step in our process here. Let me move this up here. Okay. That's what happened on this first step. Ready? Okay. So now that we've done this, we've sort of set ourselves up to get these x values and these y values, but we are going to have to do a fancy algebra trick here. Okay, I'm definitely going to call it that. It is a fancy algebra trick. Okay, what we need to do is we have to add something to this side, to this expression here. You don't have to write this, but we need to add a number to this term so that I can factor it into a perfect square so that I can get it here, right? I need to do that. And then I have to do the same thing to this group here, okay? But I can't just add things to one side and call it a day, right? In algebra, we know that what I do to one side, I have to do to the other, okay? So keep that in mind as we go through this. This next step is gonna seem a little bit strange, okay? But we are going to take each of these values here. We are going to operate with them separately. We're going to take this -6 and we're actually going to divide it in half. The reason we're dividing them in half is because we're looking for a value that's going to perfectly square, like be perfectly broken in half here, right? We need 2 equal parts. So we're going to split that in half, and then that gets us -3. We're going to do the same thing here. That would be -2 divided by 2, which gets us -1. Okay. Now, if you're confused why we're doing this, maybe it'll make sense in a second. I'm gonna pull everything back together, but right now let's just follow the steps. So I'm gonna start by divide 2. Okay. We're doing it by that sort of coefficient of the variable has the power of 1, right? Always taking that value. So we get -1. Okay. Moving on. The next thing we're going to do is we're going to take that and we are going to square it. The reason we're going to end up doing this is because we must make sure that that value gets squared in our equation. That's sort of the reason. Again, if you're not really following along with why I'm doing that, it's okay. All right. So we're going to get, I'll write it in red here so it's easier to see. We're going to get 9 here, right? Okay. And I'll put the little square symbols. And then we're going to get 1 here. Okay, so what we're going to do is we're going to add these values to both sides of the equation. Each value goes with its variable side. And so let's make sense of this. Back up here, we had our original equation. So I'm going to rewrite that. And I'll start it in black text. And I'm going to keep this like this. So it's x squared minus 6x. And then we're going to add this 9 to it, right? There's that additional 9. That's where it goes. Then we take this y expression here. We're going to add 1 to it. And then that's going to be equal to 71. Now, I can't just add these red numbers and act like everything's okay on the right side, because it's not. What I do to one side, I have to do to the other. So we're going to add 9 here and add 1 here, okay? So now all we've done is we've added 10 to both sides, okay? In sort of a fancy algebraic way. That's really what's happened. We've just added 10 to both sides through a special way. So now we're almost done. We are going to factor each one of these. That means I need to break this into its factors. So what is this going to factor into? So that's something you learned in iMath 2, and we practiced it earlier in the year. What is this going to be? Well, it's going to be x minus 3 and x minus 3, right? This one here is going to be x minus 1 and x minus 1. All right, and that's going to equal over here. We add all these together, we get 81. Now what you're going to notice is, and let me write a step here. So this step is factor the quadratic. One of our factoring methods. There we go. So we're definitely getting our algebra back out here. And you'll notice we're now in that form that I wanted right here. Right? We're in this format. So now we're just going to put the bow on this and rewrite it in its final equation of a circle form, because we have what we need, which is going to be x minus 3 squared plus x minus 1 squared equals 81. And we're done, okay? Through algebra, we've been able to manipulate this circle equation into its actual form, okay? And what we've done is actually a process called, and you can put this, or write this. This process is called completing the square. And if you continue to take math through college, if you take pre-cal next year, I don't know if they really talk about it, but it may come up again. You'll hear it, completing the square. This really is, in essence, what you do. We haven't really done it a lot in the integrated classes because we have other ways of factoring, but you'll see that it is necessary here to do this. So you can add that at the end. But let's go ahead and write out what is the center of this circle. Well, we look here, and we already practiced this. This is going to be 3 and 1. So that's going to be the center. What's the radius? Not 81, right? We have to square root that, and we get 9. So it's 3, 1, and 9. 3, 1, 9. Okay, and we did it. Now, looking at Delta Math, they call it the magic number, okay? I don't really like to call anything in math magic because it's not magic. It's not like something that we just create. What we did was we found numbers that were going to help complete the square, to make these perfect square values here. That's really what I'd rather call it. It's helping create the square. We added 10 to both sides. Look how they have that there. That's what we did. That's all we did. If you think about it, we just added 10 to both sides, and we were able to factor it, okay? That's in essence what we did. So, I mean, if you want to call it the magic number because it helps you remember it, go for it. Fine with me. But, you know, I'm a little hesitant to call math a magical thing. It is a structured operation that occurred there, okay? Nothing really magical happened. We used our brains to, or this process, which is, you know, thinking for that. But again, if it helps you remember the magic number, okay, you can go with that. So we have that. Let's do one more example and then we'll wrap up this video. Let's see, we're 15 minutes in. I like these short videos. I think that, you know, obviously students enjoy the brevity of a video. And it's quality, not quantity, right? So hopefully once we do this one, you'll be feeling more comfortable. Again, if you are struggling with this, you want me to work an example for you, just send me a message and I'll be glad to do that. It's no problem, okay? You've got a lot of practice to do with these. Let's go ahead and answer this one. So you can put example 2 in your notes. I am going to go faster on this. So remember, the first process that you should be doing is organizing these by their similar variables. And we want to make sure we move this constant over. We don't need this over here in our factoring process. So I'm going to subtract that 67. So we're going to get x squared minus 8x. I like to put these in parentheses. Know that, hey, these are grouped up. These are going to be grouped. Okay. Now, the magic number, right? No, it's not a magic number. Let's just find the value. I'll color code it again. Let's find, we have to divide these values by 2, right? So we go down and divide by 2. So we get -8 divided by 2 equals -4. Okay. We divide these by 2. Okay. And then we just have to square them. Okay. So this gets us 16. Let me write that in red just because that's what I showed last time. So we'll do 16. 1 squared is 100. All right, so we take those values, we add them to their corresponding x or y, and then they have to also go on the right side. So we're going to rewrite this. We go x squared minus 8x plus 16, parenthesis, y squared plus 20y. We add 100. And then we have to add that to the left side. So we have that -67. We're going to add plus 16 plus 100. Okay. So we're going to go ahead and start simplifying this. I'm going to go ahead and factor, right? So this is going to break into x multiplies to get 16, adds to get -8. Well, it's going to be -4. X minus 4. Hopefully y'all are noticing a pattern. I'm going to point it out after I finish this process. This is going to be multiplies to get 10, adds to get 20, positive 20. Well, this is plus 10. Plus 10. We add all these together. I'm just going to use a calculator. 67 negative plus 16 plus 100. So we get 49. By the way, these numbers over here on the right side, it should always be a perfect square. Pretty much always. I think for these examples, it's always. I can't say always. There may be examples that I give you that aren't delta math, where you would have to just take the square root of it, but that would be fine. And let's put it in our final format here. So this is this one. So we do x minus 4 squared plus y plus 10 squared. Uh-oh. Equals, and we have 49. Yeah, 49. All right, there's our equation. So the center Tell you one thing about this year. I've gotten really good at writing with a mouse. All right, so this is 4 and negative 10. Remember, we got to change the sign of that 10. And then the radius, r is equal to, we've got to square root this 49, so we get 7. So let's go back to delta math. So we got 4, negative 10, and then 7. Should be fine. We got it. You'll notice a pattern here, by the way, that actually can help speed this up for you. I mean, I want you to practice the process of this, but it's going to end up doing the same thing. Notice the green numbers. When I half them, this negative 4 and this 10, that's automatically going to be what goes here, okay? Like, that's what your factors are going to end up being, by the way. But the reason it's important to do this is to get the square values, because those have to go, you have to add that to the right side. So obviously, if you're understanding that process pretty well right now in your mind, you know, I'm going to allow you to work a little quicker on it. It's fine. But, you know, see the patterns there. If you're not really seeing that, you should definitely just start practicing these one step at a time until you feel very comfortable with the process, right? That's the idea, okay? So, all right, that should be it for this 21-minute video. Not bad. If you have any questions or need any additional help, please reach out to me. I'll be glad to help you out. Good luck, and I'll be putting out another video. Let's see, today's Thursday. I probably will wait till next week to put out the next video. I may add some other things tomorrow, but this video, we're taking it kind of slow. Remember, the test will be next week, Thursday, Friday for you all. So, and we really don't have too many more topics left. So this has been sort of a casual unit here, especially with ACT happening. Anywho, I'm going to end it there.